Hello, my name is Mr. Johnson. I am one of the chemistry teachers here, and this is the beginning of the second trimester, or the second section as you call it, of chemistry. This is the beginning of Chemistry 2. And in Chemistry 2, we do deal with there is quite a bit of math. It's fairly easy math, yet there is quite a bit of math, and you will definitely need a scientific calculator. And if you're thinking, my phone will be fine, your phone will not be fine. You definitely are going to want and you're going to need a scientific calculator for the class, for tests, for homework, etc. On a test, I will not let you use a cell phone, so you will need to have a scientific calculator for this second part of the chemistry year. So one of the things that we use a lot in chemistry is a term called the mole. Okay, and you've probably heard that word before. You might think it's that little animal that lives in the ground. There's actually a different pronunciation for mole, which is mole, which is a Mexican sauce made with sometimes chocolate and chili peppers. It's super duper good if you've ever had it. Sometimes you use the term mole when you're talking about somebody who's a spy or something who's worked their way into a country or a different company or something like that. Okay, but in chemistry, a mole is just a number. Okay, the word a mole, so 1 mole of something, is just all that it means is it means this number right here. It means 6.02 times 10 to the 23rd. Now right away, hopefully you realize, that's maybe one of the reasons why I need a scientific calculator, because 6.02 times 10 to the 23rd is really that number right there. Okay, and of course we don't want to write all those zeros every single time, which is why we put a number into scientific notation. Okay, so anytime we say a mole, we're really saying 6.02 times 10 to the 23rd. Okay, it's just like in English how we use the word, or any language, a dozen. Okay, if you say a dozen, you think 12. But I say 12 what? Well, it could be 12 whatever. Okay, it could be roses. Sometimes we talk about a dozen roses. I'm going to go get a dozen donuts. I'm going to get, a dozen pair of shoes. It doesn't matter. When you say 1 dozen, that equals 12. So just the same thing, when I say 1 mole doesn't equal 12. 1 mole equals 6.02 times 10 to the 23rd, whatever. Again, it doesn't matter what it is. It could. Now, usually the terms we use in chemistry are like atoms or molecules or particles. Okay, how many water molecules are in a container, a cup of water, things like that. Okay, and we're going to do some calculations with it here in just a minute. So this number, this 6.02 times 10 to the 23rd, this number is called Avogadro's number. There's an old scientist named Amadeus Avogadro that kind of came up with this idea of, hey, let's stop using these huge numbers, right? And let's use some numbers that are a little bit more understandable. I mean, that's kind of the reason behind the term a dozen, because apparently the number 12 is so big that it's like, 12, it's just too much to say. So I'm just going to say 1 dozen or 2 dozen or 3 dozen. Okay, so just like 1 dozen oranges has 12 oranges in it, 1 mole of, again, whatever, in this case I said hydrogen atoms, contains 6.02. So notice how 1 dozen became 12 and 1 mole becomes 6.02 times 10 to the 23rd, whatever, in this case, hydrogen atoms. Now, like I just said, why do we use these numbers? Why do we use moles in chemistry? Again, it's super duper common. We're going to use moles a lot for pretty much the rest of the year. Everything else we're going to learn the rest of the year is all going to be based on moles. And the reason is because, again, if you think about just a regular glass of water, and if I ask you, how many water molecules are in there? The number's so big that it's hard to really even say how many water molecules in there. But because you can convert that to moles, you might say, there's probably about 2 moles of H2O in a glass of water. Isn't that a much more reasonable answer rather than, well, Mr. Johnson, technically there are 1.204 times 10 to the 24th water, you know what I mean? if we can get away from using such big numbers that our brains can't even comprehend how big these numbers are, okay, it makes it much, much easier. So let me kind of give you an idea how big this number is. First of all, let's put some commas in here and kind of make sure I put the right number of zeros, which I did. Okay, so these are hundreds, thousands, millions, billions, trillions, quadrillions, quintillions, and this, I believe, is actually 602 sextrillion. Okay, that's how big that number is. Again, a number our brains can't even really comprehend. Here's an idea of how big it is, okay? If you had this many dimes, so those little tiny coins that are super thin, really small. Let's say you had a mole of them. You had 1 mole of dimes, and you started putting them all over the state of Texas. Okay, you would not only cover the whole state of Texas, but that pile of dimes would fill up the whole state of Texas and then go up 183 miles into the sky. Okay, it's not one stack, it's covering the whole state of Texas and then going up 183 miles. That's a lot of dimes. Okay, what if you took a piece of paper? What if you had a mole of pieces of paper and you stacked them on top of each other? Okay, that stack of paper would go all the way to the moon and then halfway back to Earth. So hopefully that gives you an idea of how big this number really is and how hard it is for us to comprehend it, which is why we use moles. Okay, now let's use some real chemistry examples. Let's say you only have 18 grams of carbon. And 18 grams of carbon, which again, what's a gram? Well, in 1 pound, there's about, again, I'm rounding here, 454 grams. So if you've only got 18 grams, you don't have very much carbon. But if you do, if you have 18 grams of carbon, you have over 9 times 10 to the 23, so even bigger than this number, atoms of carbon. Ugh, that's a lot. Okay, if you have 37 grams of CH3COOH, okay, that's going to contain 1.49 times 10 to the 24th hydrogen atoms. Again, some really, really big numbers. They're so big, we can't even really begin to comprehend how big they are. So again, why do we use moles? Because instead of saying this number, you know what that really is? That's 1.5 moles. Oh gosh, that's way, way easier, Mr. Johnson. I agree. Yes, it is much, much easier. Okay, and this one here, let's see. That one is about 0.6 moles. Okay, again, much, much easier. And again, we haven't talked, wait, how do you know that? We haven't talked about that yet, don't worry. Okay, so, because again, moles provide an easier way to express the amount of a substance without using such big numbers. So, just like with the dozen, which you can probably do in your head, we can use moles to convert to a more usable and reasonable number. So here's an easy example to start. Let's say you start with 72 roses, okay? And you know that 1 dozen equals 12, in this case, roses. Okay, notice that my math here, what I'm doing is I'm taking the number that they're giving me in the problem, and then see how it's roses here? So I have to put roses on the bottom here. This is just doing some basic converting. Okay, and so notice I put 12 roses on the bottom of my fraction here. And the reason that I do that is because now watch, roses over roses. Just like 5 over 5 cancels and it equals 1, roses over roses, when you have the same units on the top and on the bottom, they also cancel. So we put 12 roses on the bottom so that roses will cancel. And then on the top, we put what 12 roses are equal to, which is 1 dozen. Now I go to my calculator, and in my calculator, I'm going to type in 72, start with this number, times 1, because it's on the top, and then I'm going to divide by 12. And notice that my answer comes out to be 6 dozen roses. Okay? So, now that's obviously a non-chemistry example. With moles, you can use the same conversion, but instead of saying 1 dozen equals 12, we can say that again, 1 mole equals 6.02 times 10 to the 23rd. Now you will notice, I already did it and I'm going to do it a lot. Notice that apparently the word mole is too long and so they abbreviate it. So instead of writing MOLE, many times you will see moles, and you'll see it down here in example 3. See it right here. You'll see they will abbreviate, and I do it as well. Just put, that E is too much to put on there, so I'm going to leave it off. Okay, so how many moles are there in 9.35 times 10 to the 24th atoms of carbons? Now, again, it doesn't matter what that part is, okay? Because in this case, 1 mole is going to equal 6.02 times 10 to the 23rd atoms of carbon. Remember that it can be anything, just like a dozen can be donuts or shoes or flowers or whatever. Same thing with a mole. So in this case, what do? Well, we start with the number that they give us, 9.35 times 10 to the 24th atoms of C. And that part's really important there. Don't leave that part off. So now you know what part goes on the bottom. The atoms of C goes on the bottom. And then what goes on top? Whatever that's equal to, which is 1 mole. And now atoms, again, are going to cancel. So now is where I need to go to my calculator. And I'm going to type in 9.35. And you probably have a button that looks like this, EE, maybe EXP, or maybe it's even times 10 to the Y or something like that. And then I'm just going to type in 24. And then I'm going to multiply by 1, and I'm going to divide by 6.02, and then exponent 23. And when you do that, again, you should do this on your own calculator to make sure you get it right. You should get that answer. Obviously, I rounded there, okay? And notice that in order to convert to moles, so to convert to moles, you divide by Avogadro's number. In the next example, look at example 3. Look at what we do here. When we have moles, and they're asking us to convert to something else, notice that we're starting with moles, so the 1 mole part has to go on the bottom. There should never, ever be a question about what goes on the top and what goes on the bottom, because whatever these units are here, that's what must go on the bottom here. And it's always 1 mole equals 6.02 times 10 to the 23rd, whatever. So in this case, since they're asking us for molecules of CH4, 1 mole equals 6.02 times 10 to the 23rd molecules of CH4. Okay, and you could even add that here on the end, molecules of CH4. So again, when I put this in my calculator, I'm going to go 2.34 times 6.02 and then exponent 23, and then I'm just going to hit equals. The ones you can basically ignore. If you divide by 1 or multiply by 1, you end up getting the same thing. Okay, let me do a couple of examples for you, and then we will be done with this lesson. So we've got 5.62 times 10 to the 22nd. In this case, it's particles. And remember, 1 mole equals 6.02 times 10 to the 23rd, whatever. So what's my whatever in this case? Well, they've given me particles. And it doesn't matter if it's CuCl2. I can put that in there. Okay, because now I can say that because I have particles up here, I have to put particles on the bottom. So this means this is, for this problem, it's particles of CuCl2. So 6.02 times 10 to the 23rd particles of CuCl2 is equal to, that's what goes on the top, 1 mole. Okay, and so now I can see that particles of CuCl2 are on the top, they're on the bottom, they cancel. All I have left is moles. So now I can go to my calculator, 5.62 times 10 to the 22nd, divided by, and again, so I forget the 1. You can multiply by 1, but again, you don't need to because it gives you the same answer. So then I just divide by 6.02 times 10 to the 23rd, and I get 0.0934 moles of CuCl2, and that is my final answer. Notice that I have 3 digits here. In my answer here, I do have 3 digits. That 0 right there does not count. So whenever you're putting a mathematical answer, you want your answer to reflect how many digits are in your original number. You have the same number of significant figures. Okay, and then example 5, our last one here, we've got 2.43 moles of H3PO4. And so in this case, again, always just start with this. Start with 1 mole equals 6.02 times 10 to the 23rd, whatever. Just like we can say 1 dozen equals 12, whatever. In this case, they want molecules of H3PO4. So we know that 1 mole is going to equal 6.02 times 10 to the 23rd molecules of H3PO4. Okay, so if I have moles of H3PO4 on the top, that's what has to go on the bottom. So I'm going to put 1 mole on the bottom, and that's going to equal 6.02 times 10 to the 23rd. And here's one of the great injustices in chemistry. For moles, it's like the word mole's too long, M-O-L-E. Oh, we got to make that shorter. Let's just put M-O-L. Okay. But then we have the word molecules. Can we abbreviate that? No, we cannot, which doesn't make any sense. Anyway, so molecules you do have to write out just so you don't confuse it with moles. You can see that moles here are canceling. So I'm going to take 2.43 and I'm just going to multiply by 6.02 times 10 to the 23rd. And again, this has 3 digits, so I'm going to use 3 digits in my answer. 1.46 times 10 to the 24th. What? Don't say moles, because moles canceled. 1.46 times 10 to the 24th molecules of H3PO4. Okay, and that is your introduction to moles.